Alright, let me break this down for you here. Let's think about this stuff just a little bit different. See, I got it set up here. Let me just do a little quick flash for you. We're going to be using some of this, some of this here, some this over here, and I might go dig up some more stuff while we're chewing through the material, but I really want to make sure that you do fully understand the base mechanics here. This is the stuff that you will always use. This stone mill or whatever building you come from, percentageably, in this first part, binarily, Maxwellisms, not just the Bell's inequality. Bell is going to limit what Maxwell is not going to do to the CT paradox of the wet dry line of the pitch roll and yaw on this here stone, which gets us into XY and any flavor of Z that we might be in, or excuse me, D, difference here to X and Y, the measurement differentials, and some of this is a perception thing as well for Schrodinger's kitty cat. What if we were all using this system for the percentage?
Quantum entanglement is one of the most mysterious phenomena in existence.
Multiple frame sets in a train
seems to indicate
model
that messages can be sent from one particle to another instantaneously,
we are moving in
even
the right
if the two
direction,
particles
Space
are
Marine.
located on opposite sides of the universe. However, according to Einstein's theory of relativity,
So
no information
it's not just
can
that there
ever
wouldn't be
travel
differences.
faster than the speed of light.
I'm a relative
According to
accelerated
Einstein's theory
moving
of relativity,
frame.
if a message could
Against
travel
this,
faster
you
than the
would
speed of light,
you would run
then it
to
would be
this
possible
frame,
to send
and then no
messages
matter where we
backwards
are
in
when
time.
you had this set up or know
Yet,
how to use it,
quantum
maybe
messages
not just
traveling
having it.
instantaneously can seem to be demonstrated by measuring the polarization
Photons.
of two
Kill ya.
entangled photons,
The minigun out.
or by measuring the spins of two entangled particles, such as an electron and a positron. The principle for quantum entanglement is the same in both cases, but in this video, we will just focus on measuring the spins of particles such as electrons and positrons.
And this is for us. Why?
And the
Because we don't have this
polarization of
equipment. We don't
photons will
have
be discussed in a
the
separate video.
sub-Planck level. We
In
have
classical physics,
we have a block
the spin
and
of
a
a
2x4.
particle can be represented by an arrow pointing along the axis of rotation.
This thing up here.
Particles spinning in opposite directions have their arrows pointed in opposite
And gravity's
directions.
hitting this stuff, beating it up, making it do all kinds of crazy stuff.
We have the
Snapshot
ability to
moments
measure the spin of the particles with a detector.
left-handedness, right-handedness,
But in
not any
quantum
angle in
physics,
between,
the
right?
detectors
But
always
cling,
provide us
detected.
with only one of two measurements, which is
Let's go.
either towards
On
the
the
red
slope,
plate
he is
or
a
towards the
Maxwell
blue
demon.
plate.
Schrodinger's
Therefore,
cat, smallest
depending on
distance,
how we
IH,
orient the detectors, we can measure the spin in only one
IH
direction at a
derivative
time.
2t. If
We
you
have
wanted
the
to make
ability
it
to
special,
produce pairs of
you can make it
particles,
special, but it'll
which
always
we
go
refer to
binarily.
as
It's
an
always going to be some
entangled
kind
pair.
of. What experiment
We
is
can
very
measure each of
specific
these
to hydrogen
particles
here.
with a separate
Alright,
detector.
well, let me bust out the scope.
If we align the two detectors in the same direction,
This
then
is
the
always
spins
going to
of
do
the
this
two
because you
particles
are
will always
duality.
be in the
It's just on the
opposite
probability
directions
when we get into this thing
100%
cooking
of the
later.
time. This is predicted by both
So
classical
up, down,
physics
1,
and by
0.
quantum mechanics.
So,
If the two
being a
detectors are
Fermilab
aligned
guy
90
talking about
degrees
quantum
to each
entanglement,
other,
this
the
is
two
a very
particles
specific
measure opposite
thesis on
spins
Feynman.
exactly
You wouldn't notice it unless
50%
you
of
saw
the
Key
time.
and you were really falling into it. Maybe I'm helping you right here. But why does
This
it not
is
go
also predicted by both
here?
classical physics
You could say
and
gamma,
by
but
quantum
X, Y,
mechanics.
and Z here.
But if the two
instead of
detectors
D.
are aligned
What's
somewhere
the
in
difference?
between these
Well,
two
D
directions,
is always the
then
difference
quantum mechanics
mathematically.
gives
If
a
you
very
do
different
that, you'll
prediction
have a
than does
key
classical
into
physics.
this number. And it's going to help you determine what X and Y are, why the
According to
calculation's
classical
this, or
physics,
one of them ones.
the angle
or,
of the two detectors
where
should
was
have
the
a
other thing
linear relationship to what
more stuff
percentage of
on.
time the two particles have spins in opposite
Now
directions.
we've got the RSI turned on down here. You can see the RSI is in been building almost near overbought territory, which happens around 70s. You don't get necessarily get a reversal the moment it hits there, but you're looking
if we're all
for
using
reversal
this,
there. You see
we'll
the
know
90
things.
down here.
Let's say
It's building,
I
it's got
change
positive
X or
cross.
Y,
These are all the
but
signs
all
that
of
you want
us
to see.
use the
Now, we've
probability
got the volume
index
profile
of,
turned on. If you're
you
not
know,
using
if
this,
technique-wise,
when we
get
actually
familiar with on your
perform the
charting
experiment,
platform.
but also
the result
have
we
it on there.
get is
If yours
always
doesn't,
the
find
one
one that
predicted
does.
by quantum
And what we're
how
mechanics,
you
banding
and not the one
perceive
these
predicted
lines.
by
You see these
classical
purple
physics.
lines
what
on
that
the
is
horizon there?
at what
We're banding these around
X
where
and
there's
Y.
chunks of volume. Now I've gone
Super
out and I want to
critical.
pick up some
Suppose
more
we align the
Super
two
critical.
detectors 45 degrees
but I'm
to
going to
each
zoom
other.
in to make it a little easier to see. So you say, well, it's not exactly perfect. Well, if we go
Did
back
I
2
miss
years, what
anything
we're
here?
looking for here is one
Classical
really key
physics
thing.
predicts that the
and that
two
is where other
particles should
people
have
train at, where
opposite
they
spins.
You're gonna
find
see it
where
quick.
the
What you would see is the
signs
register on the pin.
between these zones.
Rich's
If you're,
position.
if
Yeah,
you're
that
the
might
LA
come
wave
up
theory,
later in certain
which I
places.
not
Thank you.
all
That-
the LA
that-
wave theory
Topologies
is a
and
But
things
quantum
like that.
mechanics
For the most
predicts
part, you would
that the
say,
two
I'm not
particles
lying.
should have
So I
opposite
might not always
spins
catch this.
approximately
Stephanie
85% of the time.
halftime report or something. Some of them come on off PayPal for what it is. Okay, that's true.
Get that motor going.
And it is this 85%
Now the throw is
which
back up
actually
on it, but it's
measured.
not. It's more compressed, right? Why is the throw momentum of the base wave summer, winter, summer, winter?
However, the fact that we measure 85% instead of 75% implies an inherent logical contradiction,
Or a black hole.
leading
we
us
need
to
Goldilocks
believe that the
zone
two
here,
particles are
semi-imperial on
sending
full thought,
messages
right?
to each other instantaneously,
Soon as you hit the
with
deck
all
of
the inherent
NASA's
implications about
takeoff
messages
Thank you,
traveling
government.
backwards in time. In
So
order
it's
to
not
understand
that I am
why
right
this
now,
is the
but you should
case,
see me when I'm
let us
cooking.
first consider a simple logical thought experiment that is
Anyways.
not related to quantum mechanics or to this experiment with the
Be
measurement
careful
of
this time,
spins.
guys. They can take advantage of you just like
Suppose we
anybody
have a
else.
collection of
I'm
marbles.
not saying that this is doing that because this is what you will inevitably do. You'll try to
Each marble
try to
has
word this,
three
try to do
properties
the job,
that we will call X,
and you're gonna
Y,
try to
and
figure
D.
out what that command directive looks like, X and Y, and you know some X, Y, Z stuff about all this nonsense. They'll have their own frames. They'll have X prime
For
differences.
each marble, we are allowed to choose only one
So
of
I'm
these
grinding,
three properties
grinding
to
you in.
measure.
Gotta break you. Okay, we do a couple different ways. You can play with that geometry there. X, Y, difference. X, Y, difference.
Each of these
in a
properties
group,
can have
in
only one of
packets,
two
individually.
values, which we will
Again.
call red and blue.
However, this works out. Why
That is,
they chose
the X
number
property
theory,
of each marble
probably
can be either
hydrogen,
red or blue.
most likely. Right? You know, you would.
The Y property of each
Makes
marble
sense.
can be either red or blue.
Iron 56.
And
What's
the
that? I think
D
it's
property
20.
of each marble can
What
be
is
either
iron?
red or blue.
28, 20 something like that. I don't really remember, but it's actually iron. Fe 50 something is the most stable element in the world because everything decays to it. But cesium
Suppose
has,
that all the
I
marbles
think, the
are
most
arranged
stable
in groups of
lifespan
two.
or something like that, or the most stable element. I'm not exactly sure which it is, but you would use that.
That
so
is, each marble
when you
is
do something
partnered
like
with
that
one
at the
other
atomic
marble.
level, you know, I have 1 ounce. Once I know that this is my ping pong ball,
Each
that's what it
marble
is. I
is
don't need
separated from its
tungsten. I
partner,
don't need
and
the
the two
first
marbles are
nickel on
placed
the
on
weight or the
opposite sides
whole
of the universe.
element, a periodic table of elements on a scale to
We now
determine how much
choose
work
one
or
of the
bread
three properties to
something
measure
somebody's
for
worth.
each
What
of
I
the
need to do
marbles.
is get that subset limited to the Turing machine that doesn't need a
If we choose the same
28,000
property to measure
kilometer
for both
table
a marble
with
and its partner,
what,
then we always get the same
6
outcome for the two marbles.
trillion
That is,
dodecahedron
the
and
X property of the two marbles either both come out red
limit this game down a little bit.
or they both come out blue.
So you always using binary to do this: president, vice president, some key holder on something, X or Y,
The Y
same
property
day,
of the
different
two
day.
marbles either
They were
both come out
feeling different.
red.
The SCP had life insurance numbers, and they had to creep it in there for whatever F, X, and
Or
Y,
they both
and you
come
do the
out blue.
math on it.